My name is Marcel. I have a PhD in computer science, and I have been working in AI since 2014. 2014 was a very interesting time in AI because it was around the time that when people figured out how to actually run these deep neural networks in GPU units and actually making them um, practical. Because, deep learning has been around, or neural networks have been around for ages, but then there was nowhere really the computing power to make them happen. And that sparked, and in 2014, people, or around that time in the 2010s, people figured out how to actually make these deep learning approaches workable. And that's the time where I got into AI. That feels right now already like I am an old man telling histories from before the war, which it's not, but maybe it is. Depends on from which perspective and when you're looking back. What I do in my day-to-day life is I build applications together with my customers and clients for them, or together with them. I upskill people. I'm in a bunch of larger enterprises where we're building larger AI platforms, and I'm also the founder of a company called entAIngine. We are building a no-code platform that kind of combines different AI models together, and where you can build your own applications very quickly and very fast. So everything that you're going to hear from me today will be a mix between academic knowledge, industry experience, and just my own personal opinion to a lot of things that I've been seeing over the last couple of months and years. A little bit the plan for today. We are focusing today on generative AI, and we are focusing today especially on generative AI in enterprises or mid-sized companies. So depends on if you consider yourself to be an enterprise, but I generally speak about companies that have a certain set of processes, a certain set of overhead, and certain structures that need to be adhered to, where we're going to be talking about today. Not only I will talk a lot about processes today and about architecture of these type of, let's say, global AI platforms for a whole company. Then I will go into the topic of actually what's the deal of this, or what's the title of this webinar today, and those are the 4 types of generative AI applications, which cover about 90–95% of all of the enterprise generative AI applications at this moment. We do a short break, and then we will go into view on organizations, into platforms, and I will give you a little bit of context and give you some room to ask questions in the very end. You also have the opportunity now to ask questions. I have on my second monitor a meeting chat open. So whenever you feel that you have a question that you would like to get answered, feel free to put it there. And good morning to you, Juan. Wonderful having you. So I see what is going on there. I usually make between the different segments short breaks, and I'm trying to get to your questions as soon as I get them. So yeah, that's what is in there. And without further ado, let's get into it. By the way, this meeting is recorded. So if you folks for some reason need to leave earlier or are right now in a car or listening to me as a podcast or some sort of way, the recording will be uploaded to YouTube, and you will get an email from me with an automated email after this webinar today for a little bit about context. Emilia, the screen sharing is working?
Yes, everything is perfect.
Wonderful. You already see here the story that I'm going to tell you, and you probably have seen that interface here a bunch of different times, because this here is ChatGPT. Because a lot of people see take generative AI and ChatGPT synonymously, or are not aware on how that actually works. I don't want to go too deep into different things on the market and brand positioning and so, but what I really want to talk about that what ChatGPT really is. It is a chat interface in front of what we call today a large language model. Large language models were there before. The large language model that is right now used by ChatGPT is GPT 4.0 or GPT 4.01 or GPT 4.0 mini. So there's a whole family of different models that a chat interface basically gives us access to. And that chat interface was the thing that actually made the whole hype around large language models and generative AI blow up so big the beginning of last year, especially because literally anybody who has ever used any type of messaging app or any type of chat app really can get an answer out of ChatGPT. Yeah, because you text in the same way like you would text your friends, and you get an answer. It allows us on an enterprise level to dream a little bit about, what are the capabilities of such models, what could be the interaction patterns of such models, and how we can use these type of models to make our business better. And chatbots are really, really great when we have creative tasks that need interaction. So something where you have a question and answer type of thing, or where you're brainstorming. When you are specifically talking about processes that are always a little bit different. Yeah. I'm talking now about chatbots, not large language models. I'm talking about chatbots. Chatbot is really good when you are in a use case where you would usually earlier, before there were large language models, would have talked to a colleague. Yeah, that's what it is. But there are other use cases where this interaction doesn't really help us, but we would still we could still benefit a lot from a large language model, and that's for processes that always follow the same structure, but are a little bit different from case to case. I have here an example for you. This here is the chat of Jenny. Jenny is a financial accountant, and she has to do invoice controlling. So what she basically does is she takes her invoice, uploads it in a chat to a ChatGPT or Microsoft Copilot or whatever it's called, whatever product you prefer. And you say, hey, can you analyze it for me? First thing that I want to analyze it is this document. Does that actually have the right amount of $1,249? Takes a small second until you get the first answer from the model, and it says yes. Then the next step that Jenny wants to do, she wants to map it to a cost center. So larger companies usually have cost centers, for IT, for different projects, for whatever it is. And then she has to give context to a model so that a model in a chat interface can actually do what it is capable of, because these models were trained on a vast amount of knowledge, but that is publicly available on the internet, but your internal invoices are not publicly available in the internet. If they are, that would be quite problematic, I would say. So, but the point is that you have here, this type of working with or interacting with, in the end, a large language model feels more like you are talking to an intern who is doing piece by piece stuff for you, and you have quite a lot of overhead. So let me tell you that with a little bit of maths behind it, not complex math, but maths. So think about, you have one task that when you do it manually with no AI, takes you an hour. I don't know, let's say writing a report. Yeah. And you have to do this same task 4 times. So you have to write a report for 4 different projects. That means, sorry, that means you have basically to spend 4 times 1 hour to do the same repetitive task with no AI. When we're using now AI, and or for example, thank you, Juan. When we're using now AI, for example, with a chat model like we have it with ChatGPT, we can save a lot of time, yeah, for each individual task. So let's just assume, without making that too big of a deal, if this is now a 50% time increase, time save, or a 60 or an 80% time increase. Let's for now just assume 50. The other 50% of the time that is still there is filled by you writing prompts, making adjustments, fixing errors, or answering questions that the model has because it couldn't do its job, and waiting for the cursor to be there and have generated all of that. So that's usually how this time that remains, even after you use an AI, is being used up. So that means if you have a repetitive task, so you don't not only have one report that you need to write, but you have 4 reports, you have basically 4 times the same, I would say, 50% remaining. So, and that's not the question, is that as good as it gets? Especially when we are talking about an enterprise, where we not only have 4 times a repetition of a process, but maybe 50, 20, 200, 2000 times the same thing with slightly different documents, inputs, and context, but where generally the process is kind of the same. So, and would it not be, when we look a little bit deeper, what actually this thing is for a repetitive task? Spend a lot of time on, first of all, on writing prompts. That's what we call prompt engineering, writing the right prompts that get you the right answer in the right format at the right time. That's not super intuitive. Everybody can write a prompt, but writing a good prompt is actually pretty hard. Especially when you are in an enterprise and you want to make sure that everyone who's using this application is producing consistent outputs over and over. By the way, we have a webinar on prompt engineering that we are also going to revamp and update very soon again. But this is a big challenge that we have. You have to do quality control because often, the first answer that you get from a chat model is not really what you would like to have. So the question is really, can we optimize this process in a way better? And the answer is yes. And we can optimize this process in a way by using what we call process templates and a more efficient interface than a chat interface. Let me show that a little bit to you. When you think about these type of processes and especially the repetitions, we're talking about each repetition as a case. I was talking about Jenny, who has to do invoice controlling. She has to do invoice controlling for 3,000 invoices for a company every month. So each of these invoices is a case. Yeah. In each of these cases, she might have different type of data inputs that are either a case dependent or inputs that are just everywhere the same case. An example for case-specific input is, in her case, the invoice. And an example for a case-independent piece of data is the rules on how she has to do invoice controlling and probably the mapping of what cost center or who is responsible of what cost center. These are usually things that don't change that often. So that's case-independent data versus case-specific data. We have to think about, we are building basically a template for a process that uses generative AI in a series of small, very well-defined steps. And these small, very well-defined steps are there that you don't have to have this interaction anymore of iterating with a chat model until you have something there. So breaking down the task into small little subtasks so that a large language model can focus. That's the divide and conquer approach that you have in quite a lot of fields of business. That's what I always recommend if you have specifically complex tasks. I have a customer where we are currently looking into compliance documents and comparing one 200-page compliance document to another version of the same document. You need to break the steps down into different paths. So if, for example, go paragraph by paragraph, compare them, explain to me what the difference are, and so on and so forth. That's what we need to get here. And in that way, we are not using a chat application, but what we are actually doing is by building these templates, by creating these templates, we are building what I call an AI-based application. And the real value of that is that you are not only saving let's say this 50% one time, but for all of you are saving it when you have to spend one's effort to build a process template with AI that is doing the job. And then when you have to execute it later, you don't need to upskill anybody in prompt engineering. You don't need to give out anything else, but you need just to fill your case dependent variables, and you will save up to 90% of the time. And that's the real thing, how we create real impact for enterprises that need to scale. Yeah, you don't need to build a process template for writing a happy birthday letter to your grandma. You don't. But you might want to do a little bit of thinking and a little bit of template building if you have to write requests for proposals, or if you have to deal with suppliers, if you're in contracting and procurement, if you have one of these very tedious back office tasks that are always the same structurally, but kind of different depending on the case. And that's where the thing is really interesting. So now we talk about enterprise generative AI. We're going to talk a little bit about how usually architectures of enterprise generative AI applications look like. You see here on the right side, there is a little picture, because every time we are doing something with generative AI, we need to have some sort of hardware where a large language model or a different type of AI model can be evaluated. And that's usually more hardware intense than just making a database query, because these are models, they are quite big. That's why they're called large language models. And they are also costly to a certain extent to do these type of operations. So hardware is our base layer. Then we have the second layer here, which is the model layer. In this model layer, all of the models that you would use are residing. We have basically three different ways when we talk now exclusively about large language models, about how you can get these models. One is called AI model as a service. Best example for that is OpenAI with not only with ChatGPT, but also with the OpenAI API. In model as a service, one company is basically hosting their model on some sort of cloud infrastructure and is making it available to you through an API. You don't have to manage infrastructure or care about hardware. You only have to care about your subscription and maybe the quota that you have on your subscription on your sites to pay to use this model. Has its pros and cons. We have other webinars where we go a little bit deeper, but privacy, reproducibility, sovereignty, and integration, but that's a topic for another day. Then there's the possibility to deploy an open source model, a pre-trained open source model on your own premises. For example, the Llama model from Meta is available open source, so you can, in theory, just pull a copy of it, orchestrate it on your own cloud computing or on your own server, and make it available. And the last option is you have your own model that you build from scratch, but I would say that is relevant for none of you, at least not for large language models. You have other models that are not super big, but it's not really realistic for a company to say, okay, we're building our own LLM and we are going to compete with OpenAI and Google and Meta and all of them, because it is first insanely expensive, and secondly, you need quite a lot of expertise that is very rare in this world for actually making something that can, in the quality, work with a large language or compete with one of these large language models. Not talking that there's not a use case for that. There's a lot of very good initiatives where we're talking about industry-specific large language models. That's pretty interesting use cases. Then we have on the model layer, optionally, what we call a fine-tuned model. So fine-tuning is one of the ways on how you can, let's say, modify a model to have a little bit of additional ways of, or additional information that it can reproduce, or additional, or a different way of representing that, what you have. So languages, voice tone, etc. These models are all exposed in the end through an API to what we call the orchestration layer. The orchestration layer basically is the connection between the application that uses templates in that way, and AI models and your own company data. For most company data, the way to go for these days is using a technique called retrieval augmented generation. Retrieval augmented generation basically, long story short, we also have more material on that, but basically represents the semantics of certain text that you have in a way that we can do semantic search in a vector database. A difference between semantic search and keyword search is pretty easy. Keyword search is using the syntax of a word to look for matches, and a semantic search is using the semantics of the word. Example, if you are looking for you are at IKEA on the website, let's assume IKEA would only do keyword search, and you are looking for a seat, and you type in seat, then you will only find products that have the term seat in it. You will not find a chair, even though a chair and a seat are pretty close to each are there in terms of semantics. A seat is basically a chair without a back. With semantic search, on the other hand, this semantics of a seat is a chair without a back is encoded in a bunch of numbers that are retrievable. And that's one of the, if you ask me, much more powerful than just using fine-tuned models or fine-tuning everything every time when you change something in your data. Is actually creating and maintaining these type of vector databases, so you can have access to your own company knowledge and to your own company processes with a large language model. And bringing these things all together is what we call the orchestration. We can orchestrate in different ways, and but in the end, it's always the question on how the user is interacting with this type of application. And that's where our 4 types of applications come into play. The first thing, what you will see here in the background, software that's called entAIngine, that we are actually building here in-house at the moment, is how, and here is an example of how you make a process automation for that example that I've given you on creating invoice controlling in a process. So what you see here, let me make it a little bit of a break in here. We define here a multi-step process where we are using case-specific input context and where we are defining the prompts of each step as a template. And every time we use this template, the only thing that we are doing, we are not letting anybody prompt anything, but we are only letting people fill out the blanks in our existing prompt templates. And that's the key thing that makes all of these applications that we are building have a reproducible quality in a reproducible context. And that's the first thing that I wanted to show you. That's the AI process application. The second type of application you all know, because that's a chat application. Chat applications are great for interaction. And of course, you can also have chat applications with your own knowledge bases. This is also here on entAIngine. I was now very fast. Let me do it again. Where we are asking a certain knowledge base, and we're getting some answers back based on the orchestration that we defined. The third application is a knowledge search application. A knowledge search application uses a vector store, like I've shown you before, to basically have you see this is a Google-like interface. So you have a specific question that you want to answer, and you are getting back a list of answers together. That's the important thing, together with its sources. Because if you don't get sources, you can never really verify the correctness of your answers, because large language models have the tendency to hallucinate now and then. The example that you have here, so there's also what we built with our own software with entAIngine, where we can use custom, knowledge search type of applications. But if you're looking for something that is a knowledge search with a large language model, go to Perplexity. They basically do the exact thing, but not with company-related data, but just with data that is available in the internet. So it's what we call knowledge search. And The last type of application that many kind of underestimate is what we call the editor application. So think about how often in your day-to-day life you have processes where you need to create some sort of document, some text, something where you have always a similar structure and where you need to work on different things. Example that I have here is also with a current customer that I have. We are in the contracting domain. And we have a procurement process where a buyer is iterating together with a supplier about terms of a contract. So the process, the steps that someone has to go through that are always the same. You send out a proposal, you take back what the other side gives you as a counter proposal. You have to see if that counter proposal is acceptable for you or not. And this is also a defined process, but this defined process evolves around a document. So it doesn't evolve around the chat, but it evolves around the document. And this is the place where you also can build different templates that fill out basically different sections of a document in a reproducible way. And this is what I much more recommend as an approach than just, writing in the chat and every time hoping for the best. Only, of course, if you have reproducible processes. There is, for your reference here, later a little bit of an overview about what the strengths and weaknesses of these different things are. We are now about a little bit more than halfway through, but I want to give you a little bit of view on organizations next, because there's typically a certain process within an enterprise when they make the decision to do something with generative AI. There's a lot of companies that started out with that at the beginning of last year or this year or even very recently. So there's usually some sort of management strategic decision that say, hey, we're going to use generative AI and we're trying out if we can do something. Then you give this message to your people, and usually they come up with quite a lot of use cases, quite a lot of ideas. Everybody who has ever touched ChatGPT usually doesn't lack ideas for what this technology can do. So that's a problem that people don't have. But as a company, you can't go after every idea that someone has, where it says, "Oh, I want to use a large language model to do this process or that process." You have to get a high-level overview about all of the processes that could be impacted, and assess what is the economic potential. So, am I spending now time to build a proof of concept for a process that I have 10 times a year, and every time of these 10 times it takes me 10 minutes? Or am I going to focus on a process that I have 1,000 times a month, and every time it takes me 15 minutes for each of these instances of the process? So, and in this prioritization, there is usually a bunch of different stakeholders involved that have to pick and choose their battles. And from there is what I call the POC building phase, which is there to validate feasibility. And that's where our 4 types of our generative AI applications come into place, where people play around a little bit and start building things. Many people make here make the mistake to only focus on chat applications and not the others. But I think you have seen by what I've been saying today that there's a lot of other ways that you could. And then there is usually another selection and in an evaluation process where we are only, or where we're kicking out all of the POCs that were not successful. And we're only going for the successful ones with the most impact into the implementation phase. And this is then where you have to integrate that into your existing systems, into your existing governance structures that you have before you can go to productive use. And this process is what the standard process that I have seen in dozens of mid-sized and large-scale companies right now, and everybody is somewhere in this process. And I just wanted to give you a little bit of pitfalls and objectives that you need to that you could follow according to my experience. If you have 50 use cases, don't build 50 point solutions. use some sort of a platform for your organization where you can build these applications at scale and where you don't exclusively rely on a single point of failure to build these applications, but where you can also upskill others to build their own applications. Do not isolate the proof of concept too far from the production phase, because this disconnection might cause you later a lot of trouble. This is not blockchain. This is not a technology like quantum computing that is far, far, far away from being in a productive environment. Yeah, it is something where actually, if you do it right, the gap between you build a proof of concept and you have something that makes impact in your day-to-day business can be reasonably fast. But you need to already start thinking about the production, data sizes, where you get the information from, etc., when you are building your proof of concept, if you want to make the most of it. Please don't purchase a ChatGPT subscription for 50, 100. Last week, I spoke to somebody who was purchasing a ChatGPT application for the whole organization with 18,000 people. Don't just do that and hope that people will figure out and play around with it and something concrete will come out. Don't do that. Yeah, give them clear objectives. Give them clear ways of thinking. I know there's other people that will probably tell you differently, say there's a play around phase. People who are interested in OpenAI, ChatGPT type of applications have already seen and known what it is. Give them clear guidance on what to go for, and not just say, here it is, you all have a subscription, now make our organization better. I have never seen any place where this helped really without just letting people run. You can guide them, but you need to do that in a structured way. Don't think every solution is unique and that you need to reinvent the ring. That's why it's basically the purpose of this webinar today, is that there's these 4 different types of generative AI applications. And you can basically cover almost all of the enterprise generative AI applications with text today. You need to worry about scaling costs from the beginning, monitoring credits that you use as soon as possible. Also, because if you're always just dumping 100, 200 page documents in your applications and you say, okay, model will figure it out, you will be standing there with a reasonably big bill if you have a lot of repetitions of your process. So that needs to have some investment. And a lot of people think if they don't get the achieved quality, it's because the model is bad. No, in most of the times, it's the combination of the model and the orchestration. And this is where you have much more control about the quality of what comes out. So that's why I say, break your processes down into different steps, reduce variation as much as you can to have reproducible and high quality results. And start testing with small users, but try to not be in your own ivory tower. Evaluate the outputs with automations wherever it's possible. So that were my pitfalls and my learnings that I had from a lot of different applications with a lot of different users. I'm going to tell you a little bit about the architecture again and what I believe how you have in your organization a platform that can scale generative AI applications. What you've seen here, this application that I've shown you here in the little videos, is basically nothing else than a orchestration framework on top of what we call a business process engine. I offer this solution to others where you can go here, you can drag and drop models and you can build your own processes. I also offer that on premise, but I'm not the only one on this market. There's also others who do other things. So there's people that build their own in-house platforms for generative AI, which is usually connected to a lot of work and a lot of, I would say, data shoveling and governance overhead that you have. Then there's some people that just use complete external solutions end to end. And then there's people that use hybrid solutions, like I advocate for, with, for example, with entAIngine, with our tool, to use as the product of the external service provider, but deploy and integrate it into the existing system or that you already have. And then it becomes basically your own AI platform. And based on this platform, you can implement not only one use case, but 10, 20, 200 if you do it in the right way. And yeah, this was a little bit of my view on what I think the 4 types of applications there are. As said, this is my day-to-day business. I use entAIngine to help many different types of companies in different industries, mostly in finance and in legal, anywhere where you have a hard to automate back office tasks. Yeah. Where you need company knowledge, where you need to have break a problem down into different steps, and where you need to be on a quality level that you can send out there. Maybe with a human in the loop, maybe without, depends on where you are.